Hello everybody and welcome back to another video. In this video, I'll be talking about the integration factor for solving ordinary differential equations. Now to begin, let's see what types of functions we typically use this for. So the function that we will use this to solve is a linear first order differential equation, and that is typically given by the following: y prime plus a function of x times y is equal to another function of x, and every single differential equation that follows this format is in fact solvable. So let's start and solve this right here. So this actually has a cosine term attached to it, so you might be thinking, how do we do that? You also probably notice how we will get this by itself, and we are just going to divide everything by cosine of x. Now we have the equation y prime of x, y prime plus our sine x divided by cosine x, which is just tangent of x times y, is equal to the tangent of x. Now our integration factor can be defined as the following. So we use mu to define this integration factor, and that is equal to e to the integral of our p of x with respect to x. Now, in this equation, after you integrate it, we will have a plus c, but we are actually not going to deal with that c, as we will get another constant later, which will cancel that out, so it doesn't really matter. So we will just be integrating our p of x, which, as you can see, is tangent of x. Now, let's do that before I move on. So this mu is equal to e to the integral of tan x with respect to x, and the integral of tan of x with respect to x is just going to be the integral of sine of x over cosine x dx, and our u will be cosine x. Then du by dx is going to give us negative sine of x, so we can just substitute this in to right here, and as you can see, if you solve for our du in terms of dx, this would actually just be du divided by negative sine of x is equal to our dx, so we can go ahead and plug our u in for there, and then our du in for right there. So this gives us negative integral of 1 divided by u du, which is just negative ln absolute value of u. And we do have the plus c, but as I mentioned before, we're not going to be dealing with that. And that also helps us go like that with our absolute value. And now we are going to have the negative goes to the inside, making this the ln of 1 over u. And our u was cosine x, so this is just the ln of secant x. And we will be raising e to that power, so the ln's just cancel, so our integration factor is just going to be secant of x. Now we are going to go ahead and multiply our whole equation by our integration factor. So this becomes, let's multiply this all by the secant x, so it becomes secant x times y prime of x, oh, you don't need the of x for the y, I'm sorry once again, plus secant x tangent x times y is equal to, now we have to multiply the tan x, so this just becomes sine x divided by cosine squared x, which is the same thing as secant x tan x, but I'm just going to write it as that so we can integrate it later, because sorry for spoiling, but we are going to need to integrate that. So this you can recognize as the product rule of secant x times y. So this is the same as the derivative with respect to x of y times the secant of x, and that is equal to our sine of x divided by cosine squared x. Now we are going to integrate both sides with respect to x. Now these dx's cancel and the integration just drops out, and we get y times secant of x is equal to the integral of this function with respect to x. And this function, we will say, our new parameter, since I already did u, I will do a new one. Let's say t is equal cosine of x. Then dt by dx is going to give us negative sine of x. Now divide by negative sine of x, multiply by dx, and we get dx is equal to dt over negative sine of x, which is what happened over there as well. So as you can see, the sine of x cancel, and this just becomes negative integral of 1 over u squared with respect to u. And this is just going to give us negative times the negative 1 over u plus, let's say, c sub 2. Now that is equal to our y times secant of x. Now these just become positive, so this is just 1 over u, and then this we can just make into a different constant, which I will call c sub 1, after we multiply the negative 1 in. Since a negative constant is still just a constant, I don't see a reason to make that negative for no reason. And we get that y times secant of x is equal to 1 divided by our u value, or our t value, sorry, I put u. And that is just cosine of x plus a constant c1. Now, we are just going to divide both sides by secant x, which is the same thing as multiplying everything by cosine of x. So this all gets multiplied by cosine of x. And this just goes away, and we get y on this side. And then these just cancel out, and then we just get this multiplied by cosine of x. So our equation that we initially started off with is y is equal to 1 plus a constant c times cosine of x. So if you were to plug this into our original differential equation, it would output a true statement. So this is our function right here. I will put c sub 1 since it's still the same constant as before. But anyway, I hope you all enjoyed this video. Please leave anything that I did wrong in the comments if I did. I believe that this work is all correct, but it is possible I made a slight mistake in one of my integrations. As you can see, I did do everything in terms of du, which is going to give me the same thing. However, I'm just rambling on. So anyway, please like and subscribe if you enjoyed this video, and thanks for watching.